Good morning, Achit sir.
Good morning. Good morning. Just अशोक एक जो प्रेजेंटेशन शेयर करने वाला इशू है ना,
सर वो नाउ यू कैन शेयर सर। ऊपर में एक आपने ऐप से ज्वाइन किया है या ब्राउजर से सर?
ब्राउजर से किया है।
ओके, सो नीचे एक स्ट्रिप आ रही है, वहां शेयर ऑप्शन होगा सर।
नीचे जो ट्रिपल डॉट्स हैं, नीचे जहाँ माइक्रोफोन और वीडियो और स्पीकर है,
हाँ वहीं पर है सर।
अच्छा, वहाँ पे एक वो है। ठीक है, ठीक है। शेयर स्क्रीन।
जस्ट अ मोमेंट सर।
एक मिनट।
हाँ, जो डॉट डॉट से कर सकते हैं। यस सर, अभी आपकी स्क्रीन अब दिख रही है सर?
दिख रही है।
ये आपकी स्लाइड्स भी दिख रही हैं सर। अब एक बार फुल मोड करके देख लें सर।
अब
हाँ, स्लाइड शो में आ गया सर। इट्स विजिबल सर।
ग्रेट, थैंक यू वेरी मच।
थैंक यू सर, थैंक यू।
अब आप मुझसे से मुझे करना पड़ेगा। तो मोड में कैसे जाऊँ? तो मैं आप रिमूव कर देता हूँ, स्टॉप कर देता हूँ ना। आपने स्टॉप कर दिया क्या?
नहीं सर, आप अनशेयर कर सकते हैं वहीं से जहां से शेयर किया था सर।
नहीं, अभी मैं शेयर्ड मोड में हूँ या
आप शेयर्ड मोड में हैं सर, इसलिए आप विंडो में चले गए हैं, लेकिन शेयर्ड मोड में आप अनशेयर कर सकते हैं वहां से जहां शेयर ट्रे था। एक बार और दबाएंगे तो अनशेयर हो जाएगा सर।
वहाँ पर एक्चुअली में वो मोड आ नहीं रहा है।
सर उस बटन को एक बार और दबा दें, अनशेयर हो जाएगा।
नहीं उसमें वो अच्छा
या एक मिनट सर, मैं कंट्रोल ले लेता हूँ।
हो गया।
हाँ, हो गया सर, अभी हो गया। यस, अभी अनशेयर हो गया सर।
ठीक है, थैंक यू। चेक हो गया। So 11 it will start. अच्छा, टाइमिंग्स का कितना स्ट्रिक्ट है? क्योंकि 30 मिनट्स seems to be too short.
अच्छा सर।
क्योंकि कॉन्सेप्ट थोड़ा नया है और इन्वॉल्व है, बट आई विल ट्राई टू मैनेज विद इन 30 मिनट्स। इट मे हैपन कि 5-10 मिनट्स में ओवरशूट कर जाऊँ।
इट्स ओके सर, इट इज फाइन सर।
अच्छा, अभी जो पार्टिसिपेंट्स हैं कितने हो गए? कितने मतलब?
सर वी एक्सपेक्ट अराउंड 300 प्लस सर। अभी ज्यादातर लोग 11 बजे ही ज्वाइन करते हैं। नॉर्मली रजिस्ट्रेशन जो आई थी वो 100 के आई थी, लेकिन वी आल्सो सेंड डायरेक्ट लिंक, तो पीपल प्रेफर ज्वाइनिंग डायरेक्टली विदाउट रजिस्टरिंग सर। So we have also kind of shared the direct link to join. Registration में जो 100 आई थी उसमें मतलब it's a mix of organization from where people have actually registered.
इसमें जो नॉन टेलीकॉम वाले हैं, जैसे कि रियल एस्टेट या आर्किटेक्ट और
yes sir.
AIML ऐसे भी लोगों ने कुछ ज्वाइन किया है क्या? ये एकेडमिक भी है?
Yes sir. Even there may be participants from colleges. We have some mailing list where we mail it to engineering colleges heads and all. So generally they share with their students also, some of the students. तो कुछ वो भी हो सकते हैं सर।
जो प्रॉब्लम सॉल्वर्स है ना, एक है कि प्रॉब्लम रेज करने वाले, एक प्रॉब्लम सॉल्व करने वाले। और इसमें प्रॉब्लम सॉल्व करने वाले का बहुत इंपॉर्टेंट रोल है कि दे हैव द कैपेबिलिटी टू सॉल्व द प्रॉब्लम, बट वी आर नॉट एबल टू गेट एंगेज्ड विद देम।
यस सर।
कैसे कर सकते हैं?
Good morning, sir.
Good morning, Ashok. My voice is coming.
Voice is clear, sir. Voice and video both are clear. Sir.
Good
morning, sir.
तो रिक्वेस्ट करें मेंबर एस ऑफिस को.
Yes. Sir.
हेलो अशोक।
यस सर।
अच्छा साहब अभी कमीशन रूम में हैं,
अच्छा सर।
तो 5-7 मिनट में आएंगे। तो
ठीक है सर।
वहाँ किसी को फिर बोल करके उनका सेटअप तैयार कर देना ताकि आप एक साथ इसको भेज पाएंगे।
मैं ट्राई करता हूँ उनके यहाँ ऑफिस में।
तो अब पीएस को तो मैंने बोला है।
वही करते, पीएससी करते हैं सर।
अच्छा अच्छा अच्छा।
यस यस। वो लास्ट टाइम भी कर लिया था सर, जो हम लोगों ने प्रेजेंट किया था। कर लेते हैं सर, सेम ही लिंक है सर, सिमिलर लिंक।
सो कि स्पीकर्स तो ऑन बोर्ड कर लेना, अभी सिर्फ अस्सी नजर आ रहे हैं।
सर कल हमने डेमो सेशन उनके साथ कर लिया था। विल टेक केयर सर।
गुड मॉर्निंग सर।
सर आसित हैं सर।
हाँ गुड मॉर्निंग आसिफ।
गुड मॉर्निंग सर।
एंड राधा कृष्ण। ठीक है थोड़ा वेट कर लेते हैं, साहब आते हैं।
हाँ सर। सर।
और 7 मिनट लेट है।
यस सर। Anurodh ji, if you want to speak, I have opened your mic. Anurodh ji, if you want to speak, I have opened your mic. Please unmute and speak. You can use chat box rather. Rajesh ji, good morning.
Good morning.
We are waiting for our chief guest to join.
Okay. I will wait. Are we recording this session completely?
Yes, so if you have any concern, let us know.
No problem. I wish to record this session.
Yeah, so it is on Teams platform. So generally we record for, a subsequent view and all. If you have any issue, then perhaps we will stop it.
No issues. I would like to record the session, and we are also using Teams. So once you complete the recording, you can send through Teams. So that
Sure.
I can also share with my teams internally.
Great.
Thank you.
Yeah. Thank you. Good morning, sir. I can see our members sir has joined.
तो आपका म्यूट आ रहा है अशोक।
Sir, I have made presenter. So if mic is open from that side, can you hear, sir? From a member service office, is anybody there? Can you open your mic?
Okay, I can now hear you and see you.
Yeah, good morning. Good morning,
Good morning.
Trey Wilson, and welcome to this webinar. We are just waiting for our chief guest for inaugural session, so we'll be just starting.
You'll also need to release my colleague Tommy, the controls for her mic.
Okay, I'll just check it. Yeah, good morning, Tommy. You're now presenter. Can you hear us?
Good morning. Yes, thank you very much. That's great.
Yeah, thank you so much. Yeah. Great. So we are just waiting for our chief guest today, our member service, Dr. Mahesh Shukla. So he was in some other meeting, so he may be delayed for 5-6 minutes. So we're just waiting for him. Okay.
नंबर भी बिजी जा रही
Good morning, Sudhir ji. Welcome.
Good morning. Very nice
Yeah,
to be here.
morning,
Thank you.
Yeah. We're just waiting for our chief guest
Sure.
to join. Thanks. Shukla sir has disconnected.
नंबर बिजी हाँ जी गुड मॉर्निंग सर हाँ जी जी सर जी सर, अब
Sir has joined, so I'll just make presenter, sir.
हाँ, जब प्रेजेंटर बनाइए साहब को
बना दिया सर।
एक सेकंड प्लीज।
बना दी सर, माइक खोलें
को
सर।
सर अनम्यूट कर दीजिए। माइक अनम्यूट कर दीजिए सर। ने प्रेजेंटर अभी बनाया है सर, अभी एक बार और ट्राई।
बन के आप अब अनम्यूट कर सकते हैं सर।
अनम्यूट नहीं हो रहा है अशोक।
सर यहाँ से तो ओपन है सर, कोई अनम्यूट कर रहा है। सर को हम लोगों की आवाज आ रही है सर?
हाँ सर, हमारी आवाज आ रही है आपको? हाँ सर, लेकिन अब आपका माइक म्यूट। अभी हुआ।
अभी आ गया सर।
होल्ड करिए।
वीडियो सर, वी कैन हियर यू सर।
वीडियो भी आ गया।
स्टार्ट कर सकते हैं अभी?
हाँ सर, स्टार्ट। आपका वेट कर।
अच्छा हाँ, तो इंट्रोडक्टरी पहले कोई स्टेटमेंट आप दीजिए कोई।
हाँ सर, इफ यू परमिट सर, वी कैन स्टार्ट ना।
हाँ स्टार्ट करिए, हाँ प्लीज।
Shall we start, sir? Thank you.
Yes, start.
Thank you, sir. So, respected member services, DCC DOT, Dr. Mahesh Shukla, sir. Respected Director General NTI PRIT, Sri Raju Sinha, sir. Senior officials, my colleagues, esteemed speakers, and distinguished participants. Good morning to all of you, and warm welcome to this webinar on digitally connected building global trends. I'm Ashok Kumar, Director Wireless Access here at NTI PRIT. So I'll just introduce you to the webinar before we formally inaugurate it. So in this webinar, in addition to the inaugural session, we have 5 sessions. The first session is on quality of service and digital connectivity in indoor spaces. Second session is about planning and implementation of in-building solutions using advanced tools. Third and fourth sessions are related to rating of building based on their digital infrastructure global practices. And the last session is question and answer and final vote of thanks. I'll also introduce to our esteemed speaker before we begin. So our first speaker of the session is Mr. Ashit Kadyan. So Ashit is DDG in DOT, and he has recently joined in DOT. Back from TRAI, where he was advisor quality of service. And prior to that, Asit has worked in Telecom Engineering Center, DOT, and also at NTI PRIT. His topic is quality of service in digital connectivity in indoor spaces, making it happen. The second session is related to planning and implementation of in-building solutions using advanced tools. So we have a speaker from IBWeb, Sri Rajesh Radhakrishnan, who is team lead sales engineering. He has 18 plus years of experience in this particular telecom field, and particularly in indoor coverage solutions. So we'll hear from him in the second session. The third session is about rating of buildings based on their digital infrastructure global practices. The speaker we have today is Sri Sudhi Sinhaji, Vice President, Ecosystem and Service Development, Underwriter Laboratory. So Sudhi Sinha is having 25 plus years of experience in this particular domain. He is a digital transformation leader. He has also written a book. I was going through his LinkedIn profile on he has co-authored rather a book named Reimagining Business with Artificial Intelligence. The next speaker, we have 2 speakers from WiredScore. Ms. Thompson Crowley. Tommy is a popular name for her. She is Global Director of APAC, WiredScore. And she is also joined by Strutt Wilson, Director of Operation. Again from WiredScore. So WiredScore is known for basically digital connectivity and smart rating system for real estate as a global kind of a recognition they have, sir. So these are all the speakers and their topics today they'll be covering. So with this, may I now request our Director General Sri Raju Sinha sir for his welcome address. Over to you, sir.
Thank you, Ashok. Respected Dr. Mahesh Shukla sir, Member Services DCC, senior officers, colleague from DOT headquarters, LSAs, TEC, BSNL, MTNL, and other units. Learned speakers in the session, as Ashok introduced, Ashit Kadyan, Advisor TRI, Rajesh Radhakrishnan, IBWare, Sri Sudhesh Sinha of Underwriter Laboratories, Ms. Thomas Cawley, Global Director of APAC, and Mr. Stuart Wilson, Director Operation, Widescore. Participants from various fields, academia, research units, fellow officers from NTI-PRIT, ladies and gentlemen. It is a privilege for all of us that Member Services DCC agreed to inaugurate this webinar. So I warmly welcome all of you to this webinar. We assembled this forum to deliberate an important prevalent subject, that is digitally connected building. Building are the place we live, we work, we get entertained, we get business done, and the list is never ending. With the arrival of 5G, wireless is surely going mainstream as the default connectivity medium of choice. Its quality of service inside the building is also becoming the demanding character of the building itself. Of course, the wide connectivity in terms of copper and fiber will have its role to play. But for this, we need to have the required metrics to judge or measure a building as to how good it is in terms of its connectivity, as we were judging for other infrastructure like water, roads, etc. Someone can evaluate from the aspect of smartness digital connectivity. And globally also, this key aspect is deservedly getting its attention. It is being recognized world over that an interdisciplinary approach is required while designing the building if one has to ensure proper connectivity, not only today, but for the days and years to come. The involvement of various stakeholders, which now also includes telecom operators, OEM of telecom network, etc., is essential if this is to be achieved. This will require sustained effort over a period of time. Dear participants, we who are following among the Cambodia officers and various units, those who are following TRI must have noticed that TRI has made a very significant step in this direction by coming out with a consultation process on the topic of rating of buildings or area of digital connectivity. We also assembled today, and this webinar will enhance wider discussion within the country in this matter. This webinar, as we have seen, has brought together speakers with rich experience in this domain so that participants can get to know the concept, its global status, which can be further deliberated upon at various levels. Thank you. I again welcome you all to this webinar. Over to Ashok.
Yeah, thank you, sir. Thank you so much for your welcome address. Now, may I invite Dr. Mahesh Shukla, Member Services DCC, for his inaugural address and also declare this webinar open for further deliberations. So over to you, sir.
So good morning to all of you. I hope I'm seeing you.
Yes, sir. We can hear you, sir, and your video is also coming. Thank you, sir.
Good. So good morning to all of you. I welcome all the participants, the speakers, my colleagues who have joined this seminar on digitally connected buildings, and they want to discuss and they would like to know what are the global trends in this area. I also congratulate DGNT and his team for selecting this topic, because this is the future which we see for ourselves, that the buildings will be artificially connected, the use of artificial intelligence will increase. And I am very happy to note that one of the speakers is an expert on this area, and he will discuss how the artificial intelligence and such advanced technologies will be used or have been planned globally. I wish you success, and I hope that at the end of the lectures, at the end of the webinar, we all will go home with much richer knowledge in this field. I'm not sure that the global trends which will be learned by DOT officers here, how they can be implemented in India. For that, I request DG NTI-IPRET that after the webinar, whatever trends come out, to implement them in India, we will have a discussion after the webinar is over separately, so that at DOT headquarters, at the commission level, if certain things need to be done, we'll be able to follow it up. Because unless we implement those global trends in India, the life of the citizens and the government to citizen services, all those things will not be able to fulfill their aims unless not only we discuss but implement also subsequently and follow it up vigorously. With these words, I declare this webinar open and hand over the mic to your presenter, Mr. Ashok Kumar, to continue the workshop, continue the webinar. I would also request that personally maybe I'll be on and off, but definitely I'll be able to learn it also during the presentation, which are likely to go up to 1:30. Thank you very much.
Thank you so much, sir. And we definitely will, whatever learning comes out from this webinar, we will jot it down and maybe we'll place before you and before commission, and we'll see that what kind of policy changes may be thought of after this webinar, or what kind of other enablement which government can consider. Thank you so much, sir. And now I request my DDG B. Sunil Kumar, sir, for vote of thanks for this inaugural session, and then we'll continue with the technical session after this. So over to you, sir.
Thank you, Ashok. Respected member DCC, Dr. Mahesh Shukla, sir, respected DG, respected all my dear colleagues, speakers, and all the officers who have logged in. Very good morning to all of you. Very often, actually, it is those subtle steps that bring about fundamental and substantial changes in our system. The focus on making a paradigm shift in the way in-building coverage is being planned. That is initiated by TRAI through the consultation paper in March 2022 is one such subtle change that we are trying to bring about. The TRAI has taken that initiative. This webinar is nothing but a small effort in trying to build on the dialogue initiated by TRAI, so that this exercise becomes what can be termed as something like co-creation or collaborative creation of a regulation. So I am sure that all the executives and officers who have logged in will greatly benefit from this exercise from NTI-IPRET. So in this regard, I am extremely thankful to Dr. Mahesh Shukla, sir, Member Services, DCC, who have been mentoring and supporting us ever since he has joined this office. So thank you very much, sir, for sparing your valuable time and to come forward and inaugurate this important webinar. I will sincerely thank our Director General and Head NTI-PRIT, Raju Sinha sir, who is an officer who leads by example and the main force behind this webinar. Thank you so much, sir. And we are also extremely eager to listen to Asit Kadian, DDG DOT, who is the man behind the consultation paper and the efforts and the initiatives from the tribe. So thank you, Asit, for coming here. And also from Rajesh, who is from IB Wave, the leading IBS planning OEM globally. And also Mr. Sudhir Sinha from UL, the reputed certification company. Thomason Trolley and Stuart Wilson from Wiredsco, who are the global innovators in this field of rating of buildings. So we are having a very enriched panel of speakers waiting for all of you to deliver the sessions. So I'm sure that everyone who have logged in will greatly benefit from this 2-3 hours of webinar today. So thank you one and all, and over to Ashok.
Thank you, sir. And now we'll begin our first session. So before I hand it over to Asit Kadian, sir, let me just to all participants tell that this is Microsoft Team platform. In case you want to ask any question, you can use chat box. There is an option of chat box where you can write your question and we'll be able to take those questions just after the session. We also have a separate question answer session at the end, but during the session also you can ask through the chat box. There is also one icon of question and answer icon. There also you can ask the question. So two options, either directly in the chat box or question and answer box, which is there in the team platform on the top if you are using the app. So with this, may I request Sri Asit Kadian sir, DDG DOT, to start his presentation on quality of service and digital connectivity in indoor spaces, making it happen. So over to you, Asit sir. Yeah, we can see your screen, sir. If you can open your PPT. Yeah, right. Yes, if you can go to the full. Yes, sir. We can see your PPT. Now you can start, sir.
Thank you, Ashok. Respected member services, Dr. Mahesh Shukla, sir. Respected DG NTI-PRIT, Shri Raju Sinha, sir. Shri B. Sunil Kumar, DDG NTI-PRIT. Senior colleagues from DOT. Colleagues from the industry and other participants who have logged in. Good morning. And my session will be on quality in indoor spaces. And this presentation is based on my understanding and experience during my tenure in TRAI. So I will be presenting the ideas and the experiences which we have discussed during assessment and evaluation of quality of service and the way ahead to improve this. So what is the situation in a current state? That consumers expect a good experience whenever and wherever they are. They want to have a good connectivity, good digital connectivity. And what telco says, that they are doing their best. So whatever is possible, they are trying to do that. And what regulator is doing is regulator is trying its best to monitor the quality of service, and whatever benchmarks are set, and if those benchmarks are not achieved, then financial disincentives are imposed. This is the situation. But what is the problem? That in practice and in reality, consumers are not satisfied. It means whatever you say, that whether the benchmarks are met or not met, but people are not satisfied. They are saying that they are not happy. They want a better connectivity. And why the best connectivity should not be available. Is there a requirement to push the telcos, or telcos should do on their own? Because it is in their business interest. So if telcos will be able to give a better quality of service, consumption will increase, and if consumption goes high, then there will be a better return. So we expect that if there are no barriers, then telcos will be able to provide a best connectivity. What may be the barriers? There may be some right-of-way barriers, or there may be some investment-related issues, or there may be some skill-related issues. So there may be some issues. Otherwise, if those issues or those barriers are not there, they will be interested to give best quality of experience. And another issue is that there is a gap between assessment of the quality of service and the perceived quality. So whatever assessment we do, means we average out the call drop rate or a throughput or a latency or whatever KPIs we define for the assessment of quality of experience, we aggregate across a geographical area and we aggregate over a time period. For example, current assessments may be for 3-month period, a quarter of the year, or it may be for licensed service area. So many things gets averaged out. While in reality, quality of experience varies within the building. Means at a micro level, it also varies. With a small change in the location, you will see that there is a big difference in the quality of experience. So there are gaps. And if you are not able to measure quality in an appropriate manner, there is a chance that improvements will not happen. So why this problem continue to exist? So first and the biggest problem is a principal agent problem. Means suppose we consider a case of a residential society. All the residents of the society expects that Resident Welfare Association, RWA, elected by them, will work in their interest. But what happens in reality, RWA demands money or demands, they want to enter into the commercial arrangements with the telcos, and they expect that it will be the opportunity to get some revenue. And ultimately what happens, either the network doesn't come in that building or it is not a best network. So incentives are not aligned. Means incentives of the RWA associations, incentives of the building users, incentives of the telcos, and incentives of the skilled manpower providers or other actors are not aligned. If we change the ecosystem so that they are more aligned, then automatically everybody will act in the interest of a best quality of experience. And in the current ecosystem, the customers are actually not adequately empowered to solve their problem. They expect from the telcos that their problem will get solved, but they cannot act on their own to get it solved. So they are not that much empowered that they can build their solutions. Like in the case of the electricity, that if illumination is to be provided inside the drawing room or a study room, they can get it designed as per their requirement. And other things as well, like the security system of the premises in which they live, society, they can have their own arrangements. So they can improvise their services. But in case of telcos, it is not possible in the current state. And some customers want a premium grade. Means everybody doesn't expect that it should be of same grade. They have interest and they are ready to pay. Even if they are ready to pay, they cannot get premium grade network. They have to rely on the telcos, that some telco will be interested to create a premium grade. But why telcos will be interested? Because telco cannot monetize in that geography, particular geography, in case of a mobile services. In case of wireline, it may happen, but in case of a wireless, and the tariff plans and any other things are applicable for entire license service area. It cannot be different for a different pocket. So in conclusion, customers are not empowered to get the requisite quality of experience, and they can contribute in building of this infrastructure. So what is the typical approach or conventional approach to solve the digital connectivity issue? Is to solve the barriers. So first and the foremost barrier presented by industry or many other actors is a right of way issue, that the estate managers or the property managers are not giving permissions, or this administrative authorities are not giving permissions. So right of way issue is there, and everybody expects that if right of way issue will get resolved, then quality of experience problem will get resolved. Second proposal usually is that define in detail that what builder should do at the time of the construction. So we propose that there should be a duct, there should be some enclosures, there should be some room, a particular size of the room, and some trays should be there to lay the cable. So practically we confine ourselves to laying out the cables and provisioning for those trays and for the equipments. And we want to enforce such a code by provisions under the building bylaws. And we expect that if building codes are implemented, then there will be a good quality of experience. But what we have studied, we have studied during TRI tenure is that even if we resolve these two issues, there is no guarantee that there will be a good quality of experience, especially in case of mobile or a wireless services. Why it is so? Because in the case of a FTTH or a wireline, it is the only wire which has to be taken to the apartment or a building, and we assume that problem is resolved. But in case of mobile, wireless signal comes from windows or from many other directions, and not from the gate of the apartment. And solutions are not same because telcos have a different spectrum bands, telcos have a different vendors, and they choose a different kind of a solutions. So the problem is same, but solutions may be different. So there is not a unique way to solve the issue. So there is a feasibility region where cost optimization is to be done, or some other choices are to be exercised, and then it is to be solved. So it is much more complex than this ROW and building codes. Just by defining, we cannot ensure. These are helpful. Definitely these two initiatives are helpful, but you cannot guarantee the good quality of experience by just winning over these barriers. So this is, there are two volumes, a big volume of a national building code in India, and it is first volume is about 1200 pages. It contains development control rules, general building requirements, fire safety, building material, structural design, etc. And there is a volume 2, which is also of 1000 pages. And it includes construction management practices, safety, plumbing service, landscape, approach to sustainability and certain facility management. But this volume contains a 28-page as a part of the building services, which defines that what is required in the case of a telecom. Only 20 pages, 28 pages within this building services document. And if you go through that, it may be good for having a FTTH connectivity or a broadband connectivity inside the apartment, but it may not be adequate for good wireless connectivity. So, question arises that if can we define in more detail and make it as a part of the national building code, and once it will be there, then problem will get solved? Is it so simple to design, or it is much more complex? And how it is to be guaranteed that whatever design has been provided by the architect or a telecom vendor is a good design? there should be some evaluation. So if this is the video animation created on the basis of our experience, and if you measure the quality of experience in a multi-storied building, it is not uniform. Within a tower, means red, green, and yellow are representing a quality of experience on a different floors or on different faces of the same tower. That you can see from this animation that even if you are on the same floor and the same tower of the residential society, quality of experience may differ substantially from one part of the building to the other part of the building on the same floor. So on which face of the tower you are. So if you evaluate, or as a regulator or as a licensor, if somebody evaluates that what is the quality of experience, so one will average out the experience. And even that may happen that one may not measure all the variations which are happening in reality. And if you will average out and declare that it is under yellow zone, or it is a red zone or a green zone, but it is not representative. It is not true representative of the situation. Why it is so? A person living in a particular apartment in a red zone is always in red zone. His experience cannot be averaged out by the green zone apartment. So green zone apartment and a red zone apartment should not be averaged out and declare that this area is a good. So you need a micro level assessment. It is a heavy stuff. It is difficult to do in practice, but there are ways how it can be done and who should do it, and how it will be advantageous to resolve the issues. So important is to rethink and reimagine how the evaluation should be done and how the resolutions or remedies can be done for the problems which come out from the evaluation. This diagram is of an apartment. It is from Mumbai multi-story apartment, and it is a premium luxury apartment area. And so there are 3 apartments on one floor. So these 3, this shade defines that there are 3 apartments. And red area or a yellow area and a green area depends how many antennas you have planted and where you have planted. On the basis of that, quality of experience will differ. So you can see that even if you have placed multiple antennas on the same floor, it is not entirely green. Still, there are some red zones. So if you want to have a gold standard that everywhere it should be green, you have to evaluate at the design level and then ensure that yes, now it is gold standard. And if you want to compromise on the cost, there will be something where quality will be made and maybe bad, and you have to accept it because there is no way. So whatever is acceptable should be presented to the users and the final users of that building, how that can be done. So this diagram presents that you have to, you should have a view at the time of the construction or at the time of the design of the building, whether there will be a good quality of experience or there will not be a good quality of experience. This picture, this is from Aerocity Hotel of Delhi, near Delhi airport area. These buildings are helpful to provide coverage in the proximity areas and to have a coverage in the campus of these hotels. But aesthetically, they are so good, and they earn so much money from one room that if you propose, if you offer them that we want to put an antenna, so they will think that aesthetically it will not be acceptable to them. So they will resist, they will be reluctant. And even if if telcos offer a money or a rental for that purpose, that rental is not significant for them. Whatever they earn from the other sources, it is insignificant. That if it is not improving the, it is not in their business interest, they will be unwilling. So the point is that they may be willing if many things are taken care of at the time of the design of the building. At the time of the design of buildings means some mounting positions, electrical points, how the antenna can be housed, where the cable can be laid. At the design level, it is not only the duct part, which is mentioned in the National Building Code, which is to take cables to the apartments or take cables to the rooms. Here we may require antennas at the face of the building, exterior face of the building, because we want to illuminate in the neighborhood area. So one building may be helpful to provide coverage in the proximity areas or for their campus areas. So that those requirements should be taken at the time of the design of the building. And if it is taken at the time of the design of building, there will not be any issue related to the aesthetic part because it is part of the design. There will not be any issue related to the safety part because mounting position and other things have been taken care of. Their cost will be minimal because many things have been taken care at the time of the design. So similarly, there may be other types of buildings where it may be very difficult to put the antennas once construction is over or everything has been finished. And this, I'm citing some more examples other than buildings because these are the indoor spaces. Suppose in case of a airport metro, there may be a tunnel. So some portion may be underground and some portions may be elevated. And what interesting problem we have seen that even if there is a good coverage inside the tunnel and a good coverage outside the tunnel, even then call gets dropped and train moves out of the tunnel and train enters into the tunnel. And the reason being is that when train is moving inside the tunnel, mobile handsets are not able to see the neighboring or a cell sites where they will be handing over. Means when mobiles are inside the tunnel, they can't see outdoor networks. By the time metro comes out of the tunnel and they mobile handsets try to search the signals, it is too late and call gets dropped. Similar way, when metro enters into the tunnel, call gets dropped. So technical solution is that put the antenna at the mouth of the tunnel. All railway people are not ready to give any location of the means permission to the location to install the antenna on the mouth of the tunnel. But it is doable in other parts of the world because that is considered at the time of the design of the tunnel. When you are designing the tunnel, then you can install the antenna. You have a mounting positions and all other measures which may be the concerns of the railway people may be important. This is one more study which was a Kalka Shimla railway line, and what can be seen from this picture is that when you enter into this tunnel, at the mouth of the tunnel there is no antenna and call gets dropped. Another example is that when we want to leverage the airport metro piers for providing coverage on the roads, so some antennas are put, some straps of the are mounted, are used to mount the antennas. But it is costly affair because footprint is very small. And if we we request railway people that we can mount this antenna on the parapet wall of the parapet wall. No, they will not agree because parapet walls are not designed to mount the antennas and they are not designed to bear the load of the antenna. So again, the question arises that why if we would have co-designed it, then this problem should have been solved. So why the builders or other people are not taking adequate interest in getting created a good digital connectivity infrastructure? So what is the motivating force? When we go to acquire new office space or residential apartments, what is our interest? Which are the main things we prefer? It is location. When we purchase apartment, location is important. Connectivity is a transportation connectivity. It means you want to pick the metro train or buses or you want to take a cab, or plan and layout of that society and the price point. These are the important things we consider, or any person who wants to purchase or an organization who wants to purchase, these are the important criteria for them. Digital connectivity is not in their mind at that moment. They think that once they will occupy it, then they will decide. So what studies have revealed that at early stage, they are not considering the digital connectivity requirement, and subsequently, if they are considering, it becomes difficult. They can't change the decision. They can't change the apartment or change the office space. And if they want to get good quality network built, then it is a much more expensive affair. And it is time taking and it is expensive. So if we want to have a digital connectivity, which is not only good, but also delightful, then what is required is that users need to come together and work along with the stakeholders. So there should be some ecosystem where they can be empowered, and builders and other actors are acting in their interest. So for good digital connectivity, what is required is a good design, and good design depends on the requirements of the end users. So how to capture the requirements of a prospective users, that is an important thing. What is required is a good workmanship. So professionals and practices are important. So how to ensure that professionals are good and their workmanship is good? So certification courses helps. So in India, as of now, there is no certification course which ensures that the people who are working to build a good in building solutions will be as per the requirements. Individual companies may be taking care of, but as a market in the open public, people are not sure that these are the certified professionals and they can hire them directly. Evaluation should not be done by the party who is implementing it. So what happens that if a telco is designing a solution and telco is evaluating, so chances are that they will say that it is a good solution. So there should be some independence and third party should be involved to evaluate this. And in case of telecom, digital connectivity is good digital connectivity is a time variant, means over a period, good quality may get converted into a bad quality. And it may happen on two reasons. One may be due to the demand side and other may be on the supply side. So we need to take care that if new spectrum bands or a technology has been launched, again, some upgradations may be required or expansion may be required in the network. So periodically, it is required to be reviewed. So most important piece is that we should be very much clear that what is the requirement inside the building to capture that requirement and to design to meet that requirement. And another important aspect is that it is not only the residents of the society or the property managers of the building who are interested in the good digital connectivity. It is the users. So even in case of a residential society, there may be maids, there may be drivers, there may be a supporting staff, there may be a grocery shops. So there may be many people who will be using mobile services in that premises. So we need to take care of their requirements. So even in case of airports, what was seen is that other than passengers, there are people who are from security, CISF security, or there are shopkeepers, there are vendors, there are airlines officers operating in the airport, and there are hotel inside the airport who are consuming these services. How to take care of their requirements. This is an example that to make efficient the system of entry into the premises, there are applications in the market who are using telecom services. They are using OTP, they are using app, they are using many other things which enhances the efficiency. So it is in the interest of the property managers, not it is only for the residents. So who should be interested to create this good quality network? Builders, architects, infra developers, resident welfare associations, maintenance agencies, flat owners, even the tenants, occupants, and regulators. And they should be involved right from the conception stage, design stage, procurement stage, pre-construction stage, construction stage, post-construction stage, and upgradation stage. In this entire process, at every stage, you may be required to evaluate whether we are going in a right directions, whether we are creating adequate facilities and capacities in the network to deliver and meet the expectations of the end users. So what is the solution? In the consultation paper of TRI, what TRI has proposed is that if we rate the buildings, and then probably whole dynamics will get changed, and the things which are looked as a barrier now those will vanish, and RWAs or property managers may be interested to invite the telcos rather than asking some money from them, and create a good digital connectivity infrastructure in the interest of the building users. So if we rate, so what is the possibility is that there will be builders may be able to monetize because they can have a premium, and even the owners of the apartment and the space can get premium because there will be higher rentals. So the entire process gets triggered in the interest of the good digital connectivity. So difficult part, I mean, it is simpler to think that how they are to be rated, but there is a challenge in the evaluation and awarding a score. So what paper has proposed is that evaluation should be done at a particular spots, then it should be for apartment or a smaller pocket, and then it should go on for a larger piece. And there should be an evaluation on a performance. So it may be on a floor or column of the tower or group of floors. There may be a variety of ways through which this may be aggregated. But important is that equal weightages cannot be assigned. There is a requirement to give unequal weightages, because even if I am using an apartment, the quality of experience inside my room, in the basement, in the parking areas, or in the club area, or in the walking area, I do not give equal weightages to all the spots. So people are not giving equal weightages. In some cases, they are able to tolerate, or they don't have that high kind of a quality of service requirements. So unequal weightages may be required to be given if we want to evaluate in a manner that is acceptable to the end user. So how these weightages are to be assigned, whether the experts should give the weightages or there is a scope of a machine learning. So it is a contextual. These weightages may vary from building to building, type of building, the type of building. Corridors may be less important in the residential areas, but corridors may be very important in the airport area or a public transport hub. So weightages may vary. So one need to understand those contexts and assign the weightages. And in this area, machine learning is very useful and powerful. So the methodology may be that if whatever area one wants to rate, then there should be a list of the services, and list of services priorities may vary. Suppose in an apartment or in an office chamber, video conferencing may be too important, but in the basement area, IoT may be more important rather than the video conferencing, because IoT enabled services may be there, or smart charging infrastructure may be required in that area. So different kinds of services may be preferred in a different pockets of the building. And consumption profile may also vary. So when one has to rate the building, one has to prepare many types of lists and give some weightages, and these weightages are to be learned through a process. So there is no prescribed formula, and there may be a mix of measurements. It may include the predictions, and even the subjective assessments may also be considered. And surveys which are not just a star rating surveys, those may be insightful surveys where video walkthrough may be offered to the customers, and they can give a precise information where is a bad quality. And whenever we are using algorithms and combining data, we should be cautious that it should be protected from the biases and data poisoning. So it should be a learning-based model. And other than just an idea that platform, application, and app is required to be introduced. So some digital platforms are to be required to be introduced on the real estate side, and some digital platforms are required on the telco side. And two platforms can interact with each other, and there are platforms where you upload the building design in a digital format. Then solutions can be built where take-off materials may be there, or estimated costs may be there, and one can hire those equipments and can get installed from the certified professionals. So that is important. And applications are required to be built for learning-based mechanisms. So what is expected with this NICO system is that it will trigger collaboration among stakeholders, and there will be a race among the property managers that they will be looking for a best quality of service. And even if it is not meeting the expectations of the end users, so they will try to take actions so that it gets upgraded or it gets expanded to meet the requirements. So we have talked about the buildings. Just few slides I will mention that there are other types of buildings or areas where problem is similar. It is not confined to the buildings. Similar kind of approach may be applied in other parts of the city as well. It is an example of a Connaught Place in Delhi that if you do some testing in the outdoor area, if you go through a dry test and take measurement, you will find a good quality on the roads, good quality in the corridors. But when you enter into any shop, a Starbucks shop or a Nike shop or any shop, just when you go inside few feet, you are not able to use your data. You are not able to make digital payments. You are not able to share the pics of the goods to share with your friends or colleagues and make some decisions. Why there is a difference? Because walls are thick, and there is no connectivity which has been planned for inside the showrooms. Is it a costly affair? If you compare what they are paying, what these business people are paying as a rent of the shop, it is huge. It is peanuts if they want to build a digital connectivity for their own purposes. They will be offering good experience to their clients. Why they will not be interested? But there is no ecosystem, there is no mechanism through which they can build their infrastructure, telco infrastructure or digital connectivity infrastructure in their area. Even if they provide Wi-Fi, it is not that easy to latch on to their Wi-Fi and use. It is a airport area where quality is good or bad in different areas, and we have evaluated, and it is very difficult to judge on the basis of aggregating of the data. We need to get more involved and go into the details. So there is already a report on that public domain. And this is an example that if you want to build a good connectivity on a hilly areas, the photos may be taken from internet, but situations may be similar in mountain or hilly areas. So if road authorities or railway authorities are not ready to co-design or co-build the digital infrastructure, there is no possibility. You won't get, telco people will not get electricity, they will not get a permission to install the towers because it is a forest land, or there is no backhaul connectivity. But if railway or road authorities are collaborate and design at the time of a construction of a road or an upgradation of the road, then it is not that difficult problem. So requirement is that need of the hour is to change the approach, and there is no one size which fits all. So there may be variation on row houses or mall or a complex building. As we discussed, that it is a principal agent problem, information asymmetries are there, and the preferences are not time consistent. Initially, people are not giving due weightage to the digital connectivity. At a later stage, they are expecting that there should be a good digital connectivity. Even if builders have taken initiative to provide a good digital connectivity, we have seen that it has converted into a monopoly. So market is not functioning. So what is required is that good connectivity at a market price, not at a monopolistic environment. So in many areas, there are good solutions, but some monopoly has emerged because one person has taken the exclusive rights to provide connectivity in that area, and that entity is charging huge money from the telcos to get the connectivity. That is not a good situation. So the ecosystem should be able to take care that who should own that infrastructure. So what is required is to correctly align the incentives, and rules are to be defined in that way. And technological solutions should be available for home or businesses so they can obtain their own solutions. That is required. And the agents, in case of a estate manager or a property manager, should advocate a consistent solutions, and they should be they should help in building a good quality networks. So, so that's the last slide, that end users should be participating in this and owning it, and we should change right of way into the co-design and co-creation of the network, and national building code should be linked. That may be a requirement that experts should continue to evolve the requirements and dynamically change the requirements, and probably that piece of the code might be required to be handled by a different authority. That may be required. So final slide is that simpler solutions may not work, and things may be simple, but we should not make it more simpler. Thank you.
Thank you, sir, for a wonderful presentation. If you can just unshare, sir. So Asit sir has talked about all aspects of building connectivity, not only building, but other aspects like airport, even the tunnels, etc. And in fact, he has set the tone for the subsequent sessions. So before I hand it over to the next speaker, so there were some questions. So maybe I'll just project a few questions which request Asit sir to kindly answer those questions. So give me a moment. Yeah. So, sir, if you are able to see the three questions, related three questions, and try to answer that.
Yes.
The first question is that you talked about consultation paper. So, what are the next logical step that we can expect after the consultation paper of the TRAI? And what is the role of the government in bringing about all these changes in the process? And do you think, or do you expect that there will be an increase in CapEx and OpEx while following this model?
So I'll answer quickly. So earlier I have worked in TRI, now I have joined DOT. So this consultation paper and logical next steps will be dealt by TRAI. But I know that what are the logical steps. So after this consultation paper, industry or stakeholders have given their comments on the paper, and those are available on the TRI website in a public domain. And there will be open house discussion. So I am expecting that soon there will be open house discussion where anybody can participate. And after that, there may be changes in the regulations or some recommendations may be sent to the DOT for next actions. Then next is that what is the role of the government in this? Government's role is very much important. When market is not playing its role, then government has to help. And in this process, the ecosystem, you need to identify the different players. Which are those players? Like certified professionals, certified products, or the trainers, training courses. You have to accredit training courses. You have to design courses. Those things are to be done by some council or some government entity. It should be there. Then the important process is evaluation. So whenever somebody is evaluating, who will be evaluating? And it is a government entity or it is a recognized entity, private entity. So there may be some impaneled agencies or there may be some authorized entities who will be doing this evaluation and awarding the certificates. So there may be different models. So probably TRI will evaluate all the possibilities which will be suggested by the stakeholders. They will come out with a final thing. But government has an important role to play to initiate this process, to build this ecosystem, to happen this ecosystem in action. And third is that what is the increase in the capex or apex? I don't think that there is any addition in the capex or apex which is not giving its return. If you are investing, you are getting good quality. So it is directly related. There should not be a wastage. So how to optimize the cost? That should be the issue. It is not the cost itself. How to optimize? Whether you can purchase on a market rate, you can get it implemented from the market. That is important. Automatically, market will offer the best price. So if everything is in the control of the end user, they will, and there is an informed choice, there is no information asymmetry, then what should be the issue of the cost? Because it is in their own interest.
Yeah, thank you, sir. Thank you, sir, for answering these questions. Sir, one more request to you. There are few questions in the chat box. So whatever question you feel like answering, you can answer in the chat box so that I proceed with
Just a moment.
The subsequent sessions. So thank you so much, sir. And before I hand it over to the next speaker, I request B. Sunil Kumar, sir, to say a few words and then we proceed. Sunil Kumar, sir.
Yeah, thanks, Ashok. And before I thank Asit for his comprehensive presentation, may I ask one query? Like, I was going through some of the responses to the consultation paper which has been posted in the TRI website. So one refrain in this or one revert on this point is that there is an IP1 provider already. So will they not suffice? Is it in their scope to improve the in-building coverage? So what is your take on this? How the role of an IP1 who is currently engaged in a post facto kind of a role when building is there, whether demand is there, complaint is there, operator or on its own IP1 engages into a building and there does the IBS solution there. So now that is a current model. So now IP1 providers are a major player in this segment. So assuming that they are going to have still a key role in this new paradigm, how do you redefine their role? Whether they have to be engaged, they will be engaged right from the design of the building, whether they have to reinvent their expertise, involve some architects and civil engineers into their fold. So how do you see the road ahead on this?
Thank you, sir, for asking appropriate questions and important questions. So actual answer will be given by TRI when they will be concluding it. So I'm not part of the TRI. So I will be giving comments in my personal capacity. And what I see is that IP1s have played an important role in building digital connectivity and infrastructure over last few years. There is no doubt they have helped in improving the quality of the infrastructure. But what is lacking is that if particular building requires a good quality infrastructure, the choice is exercised by IP1, whether they are willing or they are not willing. So there may be a numerous buildings where IP1 may not be interested at all, because there is no obligation part that you have to cover 90% of buildings in such a period. There is no obligation. So IP1 tries to take their decisions on the business viability. They evaluate and they work as per their bandwidth. So if how many people they have and what is good for them. So means builders or the end users are not in a commanding position to get their good digital infrastructure. Second issue, the important issue is we have seen and during case studies was that initially, if there is a good infrastructure and that particular IP1 goes in a financial crisis, what will happen? The ownership of that infrastructure is with a particular IP1. Until and unless that doesn't get resolved, property manager is not able to get a new infra. New infra is difficult to get because again cables are to be laid out and infrastructure is to be put in. Second is that one should not damage. And so it creates a very difficult situation. And third is that IP1s come late. They are not building infra at the time of the construction of the building. They evaluate after occupation of the building and they assess many times. So fourth is that there is no evaluation by the third party. So whether quality is good or bad, whether they have factored in the requirements of the users or not, that depends upon their own experiences. So how to take into the loop the end users, how to take care of their wishes, and how to contribute economically in building that digital connectivity infrastructure. So suppose building users want a premium kind of a digital connectivity infrastructure, how they can do it? Suppose few apartments want a good digital connectivity infrastructure, rest of the residents are not interested. How it can be done? Those things are not there. So probably new ways will not harm anybody. It is some changes in the game, but it is opening up market. So if there is a X size of the market of in building, it may be 100X if you open up the market. So if you create this ecosystem, that X will become 100X, and it will create jobs. It will create jobs, it will create opportunities, and it will satisfy the users. That ecosystem will play. So IP1s are important and they have an important role to play. But we should think that how we can play a better role. If there are some changes are required, we should be ready to for those changes.
Thanks, Sid, for a comprehensive reply as well as excellent presentation. So I'm sure that the concept that you have floated will reach its fruition in the days to come or months to come at least. So thank you so much.
Thank you, sir.
Thank you, sir. Now we'll be starting our second session, that is planning and implementation of in-building solution using advanced tools. This presentation will be given by Sri Rajesh Radhakrishnan, who is a team lead sales engineering South Asia IBwave. May I request Rajesh ji to kindly open your video initially. Maybe later you can switch off your video. You can do that. Rajesh ji, are you around?
Yeah. Thank you. Thank you, Ashok ji. So,
So,
let me share my screen.
Just a moment. Let me unshare first so that you are able to. Yeah, now you can share. Yeah, thank you. Please go ahead.
Yeah.
I also request if you can open your video for some time so that participants can see you before you start your presentation.
Yeah, actually, I'm in the
Okay,
hotel.
no problem. Then go ahead. Okay. Go ahead. Yeah. Okay, fine.
Yeah. Good afternoon, all, and special thanks to respected stakeholders from DOT, NTI, and distinguished speakers to give us this wonderful opportunity to share our experience in building network planning and deployment. So myself, Rajesh Radhakrishnan, and I'm team lead of sales engineering South Asia, and I am based in Mumbai. And my colleague is also joined, who is handling the sales part of our Indian subcontinent and Asia Pacific region. She's Anamika Gupta. She's in the list. So even we all know we are living in a connected age. So once we make behind every voice call, text message, any kind of data transfer, it runs a complex network and system connected us to the world. So it comes to IBWave is a industry leading software solution for in all kind of in-building wireless and wired connectivity in terms from survey, designing, deployment, validate, and upgrade network. So today, I have a couple of slides. This is the agenda. So it's the company introduction. Then in-building solution evolution from 4G to 5G, key 5G features, 5G design best practices by using our software. And I have a couple of 5G designs with me. I would like to share with you the two screen. Then last is a question and answer. So IBWave is based out of Canada, and it is an 18-year-old company. Now we are the part of the fiber inventor Corning Technologies. So we have globally more than 1,150 customers. That means this much of companies are using IBWave globally to make and building designs. And certified professionals, it is 3,400 plus it's counting. We have many certified professionals in India also. And more than 1 million in-building wireless projects are completed by our customers by using our designs. So this is a brief about the company. Then talk about the technologies to the inside the building. To bring any technology to any kind of building, as the wireless technologies becomes increasingly complex, to build a dense in-building network, we need a standardized software platform. Otherwise, if we go with a manual options, and that might not be able to integrate with the other systems, what happens? It leads errors. So errors in your RF calculations, bill of material, and the total project cost. We will also receive design from the subcontractors, the system integrators. They might using different formats like PDF, Excel, PowerPoint, etc. So what happens with that? This is very hard to review and or harder to comply with the network performance criteria. So if we are unable to comply with the network performance criteria, the total expenses for that in-building infrastructure will be very high because we need to redesign, upgradation, everything. So that is the real cost of the deployment. So IBWave as a software solution, we have different kind of software solutions that automates and simplifies the planning and design process of a in-building networks. I start with the stadium. If you go for stadium, there are kind of two different or three different technologies has to be built. That is, one is Wi-Fi and another one is commercial cellular network. It is a 2G, 3G, 4G, and now it's 5G. And the third one is public safety. That is a walkie-talkie. Majorly security people are handling that. So IBM have a software solution which make for public safety, and IBM have a software solution which taking care the outside of the stadium, the outdoor premises for wireless planning, all the solutions which support Wi-Fi, citizen broadband, 3G, 4G, 5G, LTE, IoT, and public safety. For especially for inside the building, if it is a hotel, like a hospitality building, we have IBM Design Enterprise. It's supporting all the frequency bands. Any kind of solution, it might be a Wi-Fi solution or a small cell solution or a distributed antenna solutions or IoT solutions. Then come to a residential building. So there are different kind of solution, FTTH or Wi-Fi and passive distributed antenna system or an active distributed antenna system or small cells. So we have a software for that. For this survey, the preliminary survey, so we have a software which can be installed in a mobile platform, Android. It will collect the existing RF scenarios for a brownfield segment. If it is a greenfield segment, we can plan with the IBM solutions. So for the input for making all these kind of in-building network, it is a diagram. It can be, or it can be an AutoCAD, or it can be a Revit file, or it can be a PDF file. So more better inputs like AutoCAD and Revit file give us a more better output in terms of building modeling. So these all solutions were already used by many telecos and the bigger enterprise providers like airports, shopping malls, then the engineering and procurement companies like L&T, Wipro, the management companies. So they are, and the system integrators also, they are using IBWave solutions in India and across the globe. So this is an interesting slide. You can see in terms of number of the buildings, which is designed by IBWave, in the office building and the colleges and university, that is especially Wi-Fi in colleges and universities. Another office building, it's commercial mobile network, and the hotels. India is number one. So we are number one. So this is because recently the Greenfield 4G operator, they adopt IBWave for their complete India in-building planning. So they planned their 4G Greenfield network by using IBWave. Yep. So now I would like to touch few points, the evaluation of 4G to 5G and key features and challenges. So for 5G, networks promise to bring many technical innovation to the field of cellular technologies. 5G will be deployed over a wide range of frequency bands. As we know, it's in sub-6 and millimeter wave. So we have existing in telecom infrastructure inside the building. There's a lot of existing DAS networks, Wi-Fi networks, small cells are there, but we need to change. So there would be a general question, what is required to prepare the infrastructure for 5G in building? So there are many discussions. I'm touching into three major points. Change of the equipment. Major reason is the frequency. It's in sub-6, few changes. If it is in millimeter wave, there is a big changes. New type of antennas are required because of the 5G technology, beamforming and MIMO. Then the fiber cabling has to be needed. Then more small cell has to be deployed and new designs tools are required and new collection tools are required for validating and approving the in-building network. The second key point is upgrade management. So we need to upgrade. We have an existing infrastructure that has to be upgraded. And so we need to check how compatible is our existing network. Is that able to upgrade to 5G, or we need to create a new network, and what all the changes we need to do, and how to do that upgradation. Can we do a phase-wise rollout? All those things will be come into the picture. These are the second key points. We need to upgrade in the management. Then the capacity management. Even in 4G we have speed, but in 5G we'll get more high-speed data and low latency. So and IoTs are there, and AR and VR is there. So that is the three major changes what we need to do once we adopt 5G for in-building. Then, so this is the evolution of a design. When we started designing on paper, it was a 2D drawing, and we calculate the EARP, the effective isotropic radiating power of each antenna, and we mark the how much area the antenna can penetrate. It's in what is the radius of each and every antenna. That is a coffee cup design in 2003. Then it's developed a 2D design with the help of the powerful prediction engine. It runs the algorithm with the respective of the frequency bands. Then it runs the prediction. When it reached to 2010, it's developed in a way that the 3D models. So not only the 2D designs, the tools calculating the penetration losses, reflection, refraction, and diffraction of the wall material with the respective of the frequency bands and technology, and it's populate a 3D model with the prediction, so we can understand, okay, what is my building's coverage and capacity and quality before I implement any network. So it's a predictive analysis. And now in the new era, it is based on AR and VR, so we can go with a IBwave mobile app into a building. Then we can show to the customer, okay, this is the area we here to upgrade your building to 5G. So this is the equipment we are supposed to install here, and this is the rack, and it is the size of, and how the cable routing is going on, everything, and the prediction also we can show them with the help of VR and AR. So no need for waiting for a floor plan itself to predictive analysis. We can do that, but this is most latest way of upgrading the network. So I would like to share with you the evolution of design in the in-building wireless network. So then I would like to touch the key feature of 5G beamforming and the multi-MIMOs. So in traditional wireless system used one antenna at the transmitter end and another antenna at the receiver end. The evolution of technology allowed the use of multiple antennas in the transmitter and receiver ends to improve the spectral efficiency of the wireless communication system. This is well known as MIMO. The number of antenna elements are usually depends the number of spatial layers or streams, example 4x4 MIMO and 8x8 MIMO. It comes to beamforming. It refers to a basic formation of beam from a set of antenna elements. So you can see different kind of beam formings in the screen. It is 8x8 and 35 beams and 16x16 beams. This is the most important feature in 5G. The shape and direction of the beam you can see in the screen can be controlled based on the antenna spacing, the phase and amplitude of each antenna element. So it can be prioritized. Then the benefit is less interference and more spatial multiplexing layers, better throughput. So that is the most important advantage, better throughput and coverage and large number of users. So it is increasing the capacity served simultaneously. So now I will go through the best practices which we recommend globally while using IBwave for in building planning, especially in 5G. So IBwave can use for 2G, 3G, 4G, Wi-Fi in 2.4 Wi-Fi in 5 gigahertz and 5G in sub-6 and 5G in millimeter wave. But in this session, I'm just touching the points of the importance points while we're making a design. We need to do some technical configurations in the software. So the three important configurations is numerology and bandwidth partitioning and slot formats. In IBwave, as you see in the screen, we have option to choose the numerology. So that is in subcarrier spacing, the operator can choose as per their KPI. And with the bandwidth partitioning allows us assign different numerologies in with the same channels. That is option is there. We can select SCS and the periodicity also we can select. And the in 5G gives us more flexibility. So we can select the downlink and slot allocation and the bandwidth profile also. Then we recommend, as per our experience, the 5G deployment in the design for 5G NR profile properly in UA antenna gain, it's 6 to 7 dBi. If when designing a 5G in millimeter network that is in 24 or 25, 26 gigahertz, for sub-6, it's kept as a LTE UE, so user equipment. So this is one configuration. Anybody makes 5G designs in IBwave, they need to take care of this configuration to get a better result of the 5G network design in building. Then beamforming modeling. So IBwave have the capability to create the beamforming antennas. So it includes different kind of beamforming. We take the inputs from the technical data sheet of the OEMs and we create that beamforming antennas. So this will help the to understand the customer what is the how the beams are looks like basically, and in what even we can enable disable individual beams and multiple configurations we can do. Simulate one beam or multiple beams together. Then output map is we can show the output map based on the beamforming modeling. So any kind of antenna, any OEM. So this is agnostic of OEMs. In our database, we have 35,000 plus components, including antennas, cables, active DAS, small cells, Wi-Fi, the other network components, switch routers, and etc. So we created that with the help of the OEMs and referring their technical data sheets, and all the files what we stored in the database are tested and approved. So then finally the building modeling. So this is super important because buildings have different attenuations, different partitions are there. There might be walls in brick, concrete, then door, glass, metal, lift, staircases, inclined surface, horizontal plane. So each have their own character in body loss attenuation based on the frequency. So IBwave created from 180 kilohertz to 60 gigahertz the building body loss attenuation values, and all the values are tested and calibrated. So once we run the predictions, so IBwave have a powerful prediction engine. It's called fast ray tracing. So it is calculating the direct line of sight of the signal, non-direct line of sight of the signals, and reflected, refracted, and diffracted. Then it gives the complete most accurate prediction in terms of any technology. This is, I show here, was a sub-6 in 3.5 gigahertz and millimeter wave in 24 gigahertz prediction. We can see the changes in the predictions. So one more thing, this is a near and far field boundary. We need to or make a in-building design or a deployment. So we need to take care of that. We have to avoid any absorbing materials or reflective objects nearby the antenna. So we need to maintain a buffer distance, minimum 2 meters from the antenna, all these far field boundaries. Because this is a common practical issue in a shopping mall or a lobbies and in hospitals. Sometimes they put an antenna just above the ceiling, and that ceiling might be a metal ceiling. So it will reflect or absorb the signals. So we need to avoid this, especially in 5G, because it is in 26 gigahertz. Then I would like to share some sample designs. For that, I need to switch my screen. Give me a second. So this is a stadium design, which placed with many antennas. And this is an LTE design basically, and multiple technologies we design in this stadium. So I will quickly show 3D building. So by using the floor plan or the drawing, we can create the 3D model of the stadium, and we are simulating. You can see the legend in the right side. We can simulating the signals of each layer, including the inclined surface of the stadium. And in IB Wave, we have many rich features. We can have the complete 35,000 components in the left side. Then we have the reports here. Once you make a design, one click, you will get the complete bill of material with the cost. So from the cost estimation, we can separate what is the cost per square feet. So this will help to the real estate. As I'm referring the first presentation, this will help to the real estate to understand what is the cost if they enable the building complete digital with wireless technologies, and what could be the cost per square foot in the design level itself. So the another design which I have, it's an enterprise building. It's a combination of Wi-Fi as well as DAS building. So you can go inside the building and see the antenna and what is the coverage, and also the cable connectivity. See here one antenna they put in the lobby area, and what is the coverage here. So we have vertical, horizontal, and inclined prediction capability. Switch back to my deck. Yeah. So IB Wave's value proposition. So once somebody choose IB Wave, one software, so one survey, one person is going to the field. He can do a survey for public safety, IoT, Wi-Fi, 3G, 4G, and 5G. So involved with help of one tool. There is no need for multiple tools for multiple technologies. And one design, one format, they can make designs for all these technologies by using IB Wave. And the deployment team can share these designs by using their mobile app, and they can deploy as it is. If any changes happens in the deployment, they can change that changes from the field itself. So the software will be updated automatically and run the prediction. So example, if somebody want to put an antenna in one location, the building owner might not be allowed. It might be related to their aesthetic view, something else. So he can change the antenna location in the software itself from the field. So software will run automatically, and it will give the result of the prediction with respective of changed location. Then it go to the validation team. They can take that same file and go to the field and check the coverage, and they can cross validate with the what is predicted and what is now they are getting. And if there is any delta particular in points, the tool will show there is a delta of 3 dB or 5 dB in that point. They can do the root cause analysis. So all this exchange between data and storage of the data, that is will do IBWave Unity. It's a server-based platform. The second most value proposition is the prediction engine. This is most powerful and globally accepted fast ray tracing algorithm. As I say, it's reflection and diffraction, and we can calibrate the prediction. If it's very old building, we are unable to understand what is the wall thickness from the drawing. So we can do the calibration. We can do a CW test and put that signal into IBWave, so the tool will calibrate it. And body loss modeling also we can do, and all the antenna patterns in a 3D model in IBWave. So we can understand what is the bore side of the antenna, what is the gain related to the angles, and we can run the multi-floor predictions. Also, if a shopping mall, if you put an antenna in the ceiling, there might be void areas. So third floor, we put an antenna and we can check what is the signal strength and the quality and capacity of that network in the ground floor. So we can do that analysis also. And the other beautiful features are automatic design plan that will reduce the time for making design. Then one click, you will get the bill of material. And this is not only an access point or a small cell design. This is a complete architecture of the network cabling, including the miscellaneous like a rack, switches, rack, and power supplies and etc. And we have a cloud connectivity. Somebody use an app from the field by making a survey. He can upload that through a cloud. And we have an option for cloud prediction also. So apart from that, we supply software and we help the people to use it. We train the people. Then we have a support team 24/7 globally. So anybody have any problem while using the software, they can immediately contact support team by text message, chat box, and phone call and email. And we have a database which is having the complete knowledge of the latest solution and technology. And more than 35,000 network components and still upgrading. And we always inform the customers about the new features, and we organized webinars for the same. And we have updates in every 2 times in a year. And if somebody using it, these all are software. So the software is installed in a laptop or a mobile. If that device has got damaged, we have an option to easily transfer the licenses. So by using IBWave, we can make a digitally enabled buildings with most accurate design. So IBWave will help the customer from the scratch itself, from the design time itself. When the builder decided to construct a building, they have a floor plan. From that time, we can associate with them for a survey, designing, implementation, post-implementation validation, and the upgradation. So we are there with the complete life cycle of the project. So that's it, sir.
Yeah, thank you, Rajesh ji. Thank you, Rajesh ji, for a wonderful presentation. And you told us about the product which you have, which can do indoor planning of wireless network and other cable network. So it was a wonderful presentation. So we have captured few questions. Let me just project that so that everyone else can also see it. If you can unshare, sir.
Yeah, 1 minute, sir.
Thank you. So I think you can see the question on the screen. So, uh, are the current in-building tools capable to do accurately measure the in-building quality of service? So, design is one part, whether we are able to measure quality of service also. Then
Yeah,
what effort will be required in case, I mean, solution is to be upgraded, existing solution or IBS designed for 4G, how to migrate it to 5G? If you can answer
Okay.
these two questions.
Sure, sir. So the first question, the current in-building design, if they mention about IB wave, yes, we have options to validate the quality of service in terms of the signal to noise ratio or the throughput and the interference analysis also. Then what effort? Okay. IBS design 4G to 5G. Again, if they did a manual design, the effort is higher. They need to start the design from the beginning. If they have IB wave design, then it is very easy. Then they just open IB wave design, then just replace the component quickly and run the prediction. So that is the part of design. When it's an upgradation of a network in terms of materials and construction, then at present in India, the components which the telcos used, it support till 3.5 gigahertz, but it is most of the infrastructures are SISO, single in, single out. When they want to upgrade to MIMO, at least 4 crores for MIMO, they need to multiple cabling, but practically that is difficult with a brownfield scenario. The small cells are the best options. We need to add more small cell to upgrade the 4G network to 5G network. Even in
Thank you.
Millimeter wave also.
Okay. So thank you so much for answering these questions. Now I request my DDG B. Sunil Kumar sir to say a few words and also formally thank to the speaker. Sir, over to you.
Yeah, thanks a lot, Rajesh, for your comprehensive approach and sharing your thoughts on how to use tools to provide the in-building coverages. So we will definitely revert back to you with more queries and more support that we will be requiring, because that is one subject which is close to our heart and which is very important. So thanks a lot, Rajesh, for your presentation.
Yeah, thank you, sir. Now we have next presentation related to rating of building based on their digital infrastructure practices. So today we have Sudhi Sinha ji with us, who is Vice President Ecosystem and Service Development, Underwriter Laboratories. As I had introduced early in the session, that Sudhi ji has also co-authored a on related to AI in these aspects. So over to you, Sudhi ji. I'll just unshare. Yeah, over to you, Sudhi sir.
Thank you, Shakri. Good afternoon, everybody, and really appreciate the opportunity, and my sincerest thanks and compliments to the Institute for organizing this webinar and helping bring together some not only the policy side of it, the education side of it, but also bring the industry together, right? So this is an extremely important topic, and Mr. Kadian's presentation was very right on spot. Like, we cannot have smart buildings without having good connectivity, because that's the backbone. So today, I have a short presentation where I'll just introduce UL very briefly and introduce you to this Smart Building Assessment Program that we have created, and how do we see the future, and how can TRI, IPRIT, and other organizations from the government can actually help. So a little bit about UL. UL is a little over 27 years old. It is the world's largest, most reputed third-party testing, inspection, certification company. with operations across more than 100 countries, and we have hundreds of laboratories all around the world. We do a lot of testing around consumer devices, industrial goods, retail, textiles, different industries. We are a market leader in many of them. Annually, more than 2 billion products get certified and tested by UL, and we support more than 90,000 manufacturers, retailers, and supply chain companies with our services around testing and certification. Our core mission is to enable a more safe, secure, and sustainable world. We have a very strong foundation in a scientific approach that we take to every new service or every new capability that we launch. I've been working in the building space for a good 15 years now, and as I have studied this space, buildings have been around for thousands of years. We know that, and in some ways, there were some incredibly smart design in the architecture of some of the very old buildings, whether it were the pyramids or the temples in southern India, or even more recently Taj Mahal. And I say recently, with a smile, because of course it's several hundred years old. But if you think about modern buildings, they probably go back about 150 odd years, right? What we know today as the modern building construction, right? And largely, I would say in the last 70, 80 years, technology in some shape or size has been in those buildings, right? Starting with some early introduction of pneumatic controls in the late 50s, early 60s, to more standalone, different siloed building management systems coming in another couple of decades. And then it took, started the introduction of some digital capabilities, very early on digital capabilities in the late 80s, early 90s. Leading to more integration across different building services, building systems in the last 20 years. And I think the last 10 plus years has been very active and very encouraging in terms of the adoption of technology in the building space. And we believe, I strongly believe that in the future, we are going to see more and more transformation of how we know the buildings today. In fact, COVID pandemic globally has in many ways redefined how we think about buildings, how we think about workspaces, how we think more broadly about work in general. And buildings are now being required to support the mission of the businesses or the mission of the institutions that they house in a more profound way. So a traditionally slow-moving industry, which has gone through many phases and many changes. What is interesting to note is that the pace of change is slowly accelerating. Buildings are very interesting because they last for a long time, right? Means they last like forever. It can, an average building will last for 40, 50 years, but it will go through multiple changes, multiple retrofits, system redesign in that 40, 50 year lifetime, at least 2 or 3 major upgrades and major design changes. And depending on what building systems we are talking about, their refresh cycles could be even shorter, right? Especially like video cameras and many other sensors, they see a refresh cycle every few years. So it's a very vibrant environment in that sense, like how we have these large fixed assets, which are very expensive to build and more expensive to maintain, which last for a long time, have such a critical role to play, as the Director General talked about in his opening speech, right? We spend 80% of our lives inside of buildings, right? Whether it is our home or whether it is our workplace or some other form of building or where we visit, right? So they play a critical role. And then you have this pace of change. Now you also have expectations around health, wellness, comfort, other kinds of experiences. So it's fairly complex ecosystem that people are using more and more smart technologies to see how to address them. But buildings also have a lot of inefficiencies in how they are operated, how they are maintained, and some of it actually comes from design and the construction stage itself. I'd probably point out to maybe 5 of the top inefficiencies that I have seen in the hundreds of buildings that I've interfaced with. One is that a lot of silos. Silos are because of the way construction industry in generally operates. Like you have civil, you have mechanical, plumbing, electrical, security, other services, telecom. They're all independent silos, which go through their independent contracting phases, their own contractors, design consultants, engineers, solution providers, softwares, any number of differences. Also, you have different departments, which get engaged. So you have the IT department, which is taking care of maybe connectivity in certain cases, maybe cybersecurity. Sometimes the cybersecurity is handled by an entirely different information security department. Then you have a maintenance department, which is looking at more of the mechanical services. You have facility management, touch services. So you have different silos. There are silos during the construction phase, there are silos during the operations phase, and often they don't really connect well with each other and they don't talk to each other. But their services, their capabilities, and their efficiencies are very important for others. And connectivity is a great example to which we will get into a lot more depth in a few minutes. Right? So connectivity impacts every dimension of building, whether we are trying to drive more energy conservation, or we are trying to improve the occupant experience, or we are trying to promote safety, or we are trying